All right, we are back to iLand. Did you miss it? Well, you remember from yesterday that I said that iLand is a process-based model, which means that it has a collection of functions and models that would, at the end, try to simulate as close as possible the natural or some processes. In these functions and models, there are some parameters that there are some fixed values that describe as close as possible chemical, physical, or biological processes. What is really important when we use a model, and especially a process-based model, is to check the equations and the parameters that are in the model, so then we know what to simulate. But it's quite hard to check everything, but at least the things that are in our focus. Our focus for this study was the spruce-bark beetle module in iLand, where we checked the key parameters, and mainly because it is a biological process that is highly dependent on weather conditions. I will jump over the description of iLand because you already talked about this yesterday and everyone here was present there. So I will jump straight to we saw this yesterday, this big chart. And just a quick reminder, in iLand, a spruce-bark beetle outbreak is triggered by either by climate-sensitive background or by wind disturbance. And then every year, the processes are repeated until the outbreak is over, which is defined by the user. The processes that happen every year are those that actually happen in a bark beetle development cycle, that are dispersal, colonization, development under the bark, and overwintering. iLand also checks if the conditions are good enough to create a brood generation, a second, or if it's the case, a third generation. We evaluated these parameters that are in the black box and also those in the parameter file. And we saw that the significant changes would be in the development of the bark beetle and overwintering. So further, I will focus on these parameters. Here, just as an idea, those from the bark beetle development are related to every stage, but for swarming, not about swarming, the temperature in Finland on boreal conditions is more than 20 degrees Celsius, and then the temperature sun should be more than 60 degrees. And then under Central European conditions, the conditions are good. For a total development cycle in boreal conditions, the condition is less than in Central European. The day length that in iLand is used to calculate the second generation and the sister generation is 17 hours, while in Central Europe, 14.5 hours. And then what we found different is that the overwintering in iLand at the moment is considered that everything overwinters under the bark. But in Finland, they found, well, not only in Finland, in boreal conditions, they found an adaptation, and they migrate also under the soil, where normally there is a layer of snow, and they should protect the beetles. Just there was some empirical data, and they found out that if the layer of snow is at least 20 centimeters, then the temperature in the soil is 0 degrees, so perfect for beetles. Here, the data isn't really consistent, so we made some assumptions. And we said that, okay, 50% in soil and 50% under the bark. There were some studies that show this, but this also differs with the adjective. But we don't really have some specific, real clear studies. And in this overwintering under the soil, we also considered a percentage that would die under the soil, because we cannot assume that everything will be alive. Based on some study, we said they said 5%, and we kept with this. We certainly need more consistent studies. Okay, so we have new parameters, and now we also have an area where to test them. Our area is in southeastern Finland, where in 2010 there was a strong storm that killed more than 8 million cubic meters of trees. So that was a perfect ground for bark beetle to start an outbreak, and especially because the forest owners and managers could not remove all the trees from the stand. So then in 2012, 2013, the outbreak started. Our study area is predominant by Northern spruce, and here with red are conserved areas that were actually conserved after the storm, which means that the trees were not removed from the were left on the base. And that it's not that base, but okay, here are some dots. These are the plots that have been established between 2014 2021, where the symptoms for bark beetle infestations were recorded. And that's part of the area. So then, to test this, we prepared the project file, if you remember from yesterday, but we did some changes. Do you remember I said that there are some parameters in the black box? Those parameters are related to weather conditions that are in the physiological development pattern. We took those from the black box and we brought them to the parameter file. So now, well, for us, are in the parameter file, and we have the iLand, the air temperature, the temperature sum for the swarming, and then for total development, we move now in the project file, so the values can be changed. And having this, then we tested both parameters, we compared them, and then we did some sensitivity analysis only for the boreal, changing different values to see which ones are more sensitive. Then we also did a global analysis and sort of validation. That first we ran simulation on our landscape from Finland using the original parameters and using the boreal parameters. So in this chart here are the original and here are the boreal. Sorry, the differences will be like 5 times more with the boreal parameters, and then we ask, okay, where are these differences coming from? So then what we did, we had the original one and we only changed one value at a time. By changing the air temperature, no difference. By changing the temperature sum, this one for swarming, just a small difference. iLand, well, even decrease. Total development already brought some differences, and winter mortality even more. But here the problem is the winter mortality is the most uncertain. But this is what we have. Okay, next we are curious. Okay, when these conditions happen in year, because well, it can be different. I just did an average of the 11 years from the local area, and using the original parameters, or using the original. Using the climate data from our study, but with the original conditions, we will say that the swarming started around mid-June, but under the with the boreal conditions, the swarming started sort of end of May. And then what we see from when they practice, and then the total development is reached with the original conditions around August, and then with the boreal conditions earlier, July, beginning of August. So the differences certainly come from this. This is also important to check the parameters because, well, the processes are different. Well, this chart is more complex than I explained, but if we will have time at the end, we can come back at this and move it. One question is if the second generation would happen, because, okay, let's say that one generation is matured at the beginning of July, would it have time to mature second one? Probably not. Or maybe they do the swarming, but the next generation would not be mature to go to overwinter. And iLand considers that only the mature beetles will overwinter and all the others will be removed from the system. With the boreal conditions, well, if this first generation is completed at the end of July, then until the second part of July probably again would not be enough for the second generation to be completed. Then we tested the parameters by changing the values for swarming temperature, sum, wavelength, and the total development. And we see that the ones for swarming conditions are not sensitive to changes. Well, we saw that there are some steps in each one. The most sensitive seem to be the dayland. So if, let's say, the dayland, the beetles will require a dayland more than 18 hours, then the infestation, the infestation will decrease by 30%. And even if they would require 18.5 hours, this is minus 88. Well, this can be a question if they can survive up north, because then the day length is much more different than in south. And then with this total development again, if they develop earlier, so they need 300 days instead of 358 as we did, then they probably will have a second generation double. Okay, now for the winter overwintering, we try both the percentage of overwintering in the soil from 0 to 100%, and then the mortality in soil from 0 to 50%. So you can see that the infestation have increased with the percentage of overwintering in soil, which means that the beetles were protected under soil and more has survived. And next year they had stronger infestations. And then these the mortality in soil then, if it was higher, then it would decrease again, because then there will be fewer beetles to emerge from the soil and make attacks. But as I said here, the data isn't really clear. So somehow we were thinking to do some experiments and have some more consistent data about it in future, hopefully close future. Here is global sensitivity, where the sensitivity of all of them were put together and compare which one is the most influential. And we see that the most influential is the terms of total development and the data. That just shows the most influential one. Also the overwintering in soil, but not much. This one shows the interaction with other parameters. When the first study was published in 2017, they have done the sensitivity of some, they call them key parameters. And they included the DBH, the storm infestation probability, the distance from the kernel formula, the cohorts per generation, and the duration of the outbreak. They have found that the cohort per generation is the most sensitive, and we also found this, that here the cohorts per generation are the most sensitive to changes. The changes in our case and in their case was 20% plus minus from the original value. So here you have the values. For minimum deviate, for example, if the minimum is 12, then the infestation will increase. If the minimum, the maximum, the minimum deviate is 18, then the infestation will be low, and so on for each parameter. The cohorts per generation is based on the reproduction rate. In the file, we had 20 cohorts per generation, and while low would be 16 and high would be 24. So even at 24, if we decrease at 16, then the infestation would decrease by 80%. So that's brand new example. But what we haven't discovered to this, and now I'm trying to understand whether it is something that is created by iLand through the process, or is something that it's really true in the field. So that's something I'm trying to understand. And lastly, so that's my last slide. We try to do sort of validation with the data that we have on the field. So we use the infested volume from each plot. We brought it at hectare level. And then we did the same with the data from iLand. The infestation per stand, we brought it at hectare level. So we have hectare cubic meters of volume that per hectare in the case of plot, and cubic meter that per hectare in the case of iLand. So we could have compared. What we was looking, because we had both managed and conserved areas. So in the conserved areas, we were expecting that the values are similar or close. And in the managed area to be different, because iLand that I simulated did not have any management implemented. So for iLand, everything was conserved. What we saw in the original parameter was opposite to what we were expecting. So it was similar for the managed and different for the conserved. But then for those ones from the boreal parameters, they were similar for the conserved that we would expect, and different from managed. So this is the only validation measure that we have so far. It would be good for future to have more data, but at the moment, this is what we have. Yeah, that's what I wanted to present today. Okay.